Thank you for taking the time to attend this talk and hear me talk about orchestration and how we run over 20 million workflows every day at Instacart. So a little about me. I live in the Bay. I've been at Instacart for over 4.5 years, so kind of joined after the second wave of the pandemic, and I've seen how our systems have matured, have grown over the years as the scale has grown. I've always worked in the infra org at Instacart, started off by building low-level SDKs and platforms, and then today I work in the data infra group where I lead large verticals around data quality, data productivity, data plus AI, and of course, orchestration. So I hope you know about Instacart, but for those of you who don't, Instacart is building technologies that power every grocery transaction across the world and definitely across North America. Instacart, and we achieve that through the Instacart app, which is really a marketplace through which we offer different kind of brands to you. So you could be shopping at your local grocer, or you could be shopping at a retail brand like Ulta Beauty or PetSmart or Sephora. We work with over 2,000 retail brands. Last year in 2024, around 33 billion of GTV flowed through our systems, which amounted to close to 300 million orders in 2024, and then which resulted in about $3.3 billion in revenue. In addition to our storefront and our marketplace offering, we also have a very thriving ads business, which resulted in over $900 million in revenue just from the ads business alone in 2024. So the agenda for today, I'm going to talk a little bit about orchestration and the need for orchestration to kind of give a context and kind of level set some context. Then I'll talk about orchestration at Instacart, which is really going to be the bulk of this talk. And then I'm going to leave you away with some key takeaways, which I believe is applicable not just to large engineering teams, but also to small engineering teams as you kind of build your orchestration systems and you grow the systems as your company scales. So I really think of orchestration as like an abstraction that you can use for multiple diverse use cases. At the very low level at an orchestration system is what I call as workflows. And you can think of workflows as a mental model for your business logic. So when you talk about workflows, you're really thinking about, hey, my business logic is to do some XYZ process, and how that gets executed or how that is handled internally when it talks to the infrastructure or your data source layer is kind of like a high-level primitive that I leave the orchestration system to do. So then thinking of your business logic as a workflow, it becomes a really powerful mental model. The orchestration system is using the workflows as its lowest unit of execution. And then it allows you to manage and coordinate different workflows at like lower levels. The orchestration system also allows workflows to kind of play well with each other. It allows workflows to talk to your low-level infrastructure. It allows handling of fault tolerance, retries, backoffs, and so on. And it also takes away the complexity around data passing between different workflows. So you're really focusing on writing the business logic, like on the mental model that you've developed of a workflow, and then you're leaving the nitty-gritties to the orchestration system itself. So what that results in is a very powerful abstraction which allows you to separate your business logic from the actual execution unit itself. So you don't really care about how the actual processing of the business logic happens, and you're more interested in writing the code that powers your business. So think of it from a point of view as a platform team where you are providing a platform to your devs who are more focused on the business logic. You take away all the complexities from them. They don't have to care about retries. They don't have to care about fault tolerance or about backups. And then you kind of provide that abstraction to them. A workflow system also allows you to visualize your entire workflow in some kind of a visual setting so that you can go back in time, see what happened, where it failed, what operations it executed. And then certain systems also allow you to interact with the live workflow where, let's say, you have a long-running workflow, it's waiting for some kind of external signal to come in, and then you do a lot of the processing after that. So overall, having an orchestration system within your stack is a really powerful system to have in your toolkit. Now talking about orchestration at Instacart. So orchestration sits at the very core of a lot of the technical systems that we build. It not only powers the data pipelines, but the moment you place an order on the Instacart platform, we run a workflow. The moment we do a payment capture, there's a workflow behind it. The moment that order that you place turns into a batch, then gets assigned to a shopper who then goes to the store, does the shopping, and delivers it to your doorstep is a series of workflows on the back end. If you log on to the app, you'll see a bunch of sponsored products there. Those are workflows. So point being, workflows are very core to a lot of the operations that happen when you place an order on Instacart. The services that internally we run to create a database, to like a Golang service or Ruby service, we provision all of that through some form of a workflow internally at Instacart. Moreover, our CI/CD is written on top of a workflow system. So, long story short, again, very core orchestration systems, workflow systems, very core to Instacart operations. Now, most of you have heard about Apache Airflow. That is one of the orchestration systems we use at Instacart. Now, Airflow has been there for, I think, over 10 years. Fun fact, just today they released Airflow 3.0, which is a major step change in a lot of the different primitives that Airflow provides. And Airflow is a really powerful, robust batch processing system. It's designed in a lot of way catering to data engineering jobs where you want to run some kind of an ETL or some kind of a data quality check on top of that ETL as the pipelines as you build out the pipelines. It has a very mature open source community, and there are a bunch of vendors that offer Airflow as a service. In addition to being so diverse and so popular especially among data engineering groups, Airflow also provides a series of operators and plugins that take away the complexity of writing your own wrappers to talk to your data store of choice, your cloud provider of choice. So it's really a system that allows you to quickly get up and running because it has a lot of these hooks already provided to you. And Airflow, like I mentioned, is one of the systems we run. Now, Airflow at its core is a batch processing system. In order to achieve the scale I talked about of more than 20 million workflows a day, we need a system that has very low latency and that is highly horizontally scalable. And for those kind of use cases, we run a system called Temporal. Some of you may have heard of Temporal. It started out as an open source project and has like a long history. And it also has an open source component. So we run the open source internally at Instacart. Now, Temporal is a highly horizontally scalable system and has low latencies. And because of its low latency guarantee and its exactly once execution guarantees, we actually put temporal workflows behind a lot of the APIs and the RPCs that we have. And imagine putting those behind every payment that is happening or every batch that is going out. You kind of see how it grows in scale. And it's able to handle that level of scale. Temporal has very strong failover guarantees, very strong fault tolerance guarantees. And then it also has a stateful execution model where it saves the entire event history, kind of maintains a state, so you don't really need to think about the external persistence layer. It has supports for long-living workflows, supports external signals, and kind of overall provides a much more capable workflow system that you can put behind RPCs and run at scale. So by the numbers, we've been running Temporal at Instacart for around 4 years. Temporal today powers over 21 million workflows a day, actually, as of today. So some change in numbers. And then we started Temporal by like a very few use cases. Some of the use cases I talked about around payment capturing, our payment gateway, and then some use cases around how we display ads creative on the Instacart app. So very small use cases that allowed us to kind of justify the investment going into running a fairly large system in-house and like experiment with the open source version. And then when we were evaluating Temporal, a Temporal cloud was not a thing. So this is like pretty early on in the journey of Temporal. So we started off by using the Golang SDK and the Ruby SDK. And over time, as the system has scaled, as more and more developers and teams across the company are seeing the value in it, we have now expanded to providing the Python SDK. We run multiple clusters for better redundancy. And then in our 4 years of running Temporal, we have had less than 10 total incidents of varying severity. Coincidentally, I was giving a talk at the Temporal's first annual developer conference 2 years back. And while I was giving the talk, we actually had a pretty nasty incident. So I got a lot of messages like, hey, don't do that talk anymore. Apache Airflow has a long history at Instacart. It predates the time when I was there. And as you can imagine, like Apache Airflow is kind of the industry standard when it comes to running data pipelines. So different teams at Instacart, different groups at Instacart were running small Airflow clusters within their org. So our ads orgs were running an Airflow cluster, our data org was running another Airflow cluster, our core app was also running a Airflow cluster. Most of it around ETL and some kind of a transformation. Around 2022, 2023, we decided on using dbt as our tool of choice for data transformation. And that's when we spun up a new cluster within our data infra group, which has now expanded to be the central cluster that we are trying to merge all the other clusters at Airflow, at Instacart around Airflow. So we have a single team running this large cluster, which runs over 4,000 DAGs today. And we are slowly, quarter by quarter, half by half, shutting down smaller Airflow instances across the company and kind of folding everything into one central Airflow cluster. This cluster not only runs over 4,000 DAGs, 5,000 in total across the company, but this cluster also runs over 1 million tasks per month. And it powers a lot of our critical dbt pipelines. We've managed to run a fairly stable cluster over the years. It has support for RBAC. There's a lot of security consideration. And then we're not only just running dbt pipelines, which talk to Snowflake predominantly, we're also running a lot of Spark pipelines here. And we have also invented or like adopted a pattern where teams bring in their Dockerized app and give us like a command to run their script, be it like Python script.py, or it could be some kind of an executable. And we run that app for them using Airflow purely as an orchestrator. So we use it through, we run it through a custom ECS operator. You could just think of it like running a pod somewhere in the cloud. And this actually is a model that Airflow 3 is now made it like a marquee feature as it was released today. Now, we do run temporal and Airflow in fairly large numbers in terms of like the actual workloads we run on it. But there are other smaller orchestration systems like rake tasks, celery jobs, which we also have in Instacart at some other places, but definitely not in the volume that I'm talking about. So how do we run these large-scale systems, and how does it kind of handle the load that the entire Instacart operations has? So at Instacart, we are an AWS shop. We run our applications as Dockerized containers using the ECS primitive that Amazon has. So we deploy the Airflow services fairly standard as ECS tasks, as you can see here. If our Airflow 2 services are fairly, you can scale them up, you can scale them out as well. Those are like some of the improvements that Airflow 2 had, which have definitely been very helpful. We put all those services behind a load balancer, and then we allow the Airflow UI, our developers to talk to Airflow through the Airflow UI. And right there, we have added some RBAC controls. So certain DAGs are only visible to certain users. Certain users can only turn on, turn off certain DAGs, and so on. Our backing database of choice is Postgres, and Celery is our broker. Now at Instacart, we have built, over the years, we built a lot of tooling around how we manage large-scale Postgres deployments. Some of them are popular open source ones like pgcat, pgbouncer. So we kind of have all those toolings, and we manage the Airflow database through all that tooling. So long story short, we actually run a fairly healthy large-scale database powering this large-scale Airflow platform, such that we have never had a major database-related issue. And then the small boxes on the left side is what's the interesting part. Those are ECS tasks, which represents external workers that you can bring into Airflow. And that is a use case I was talking about, where you run Airflow purely as a scheduler, and you have like a bunch. So you being a developer could give me an address to your worker, which is running your Golang or your Ruby or your Python app of choice. You tell me how to execute that, and I will run that, or like Airflow will run that purely as an orchestration tool, and the actual execution is going to happen on the box that you have brought in. So it doesn't put any load on the central Airflow cluster itself or on the workers, so you're able to scale out infinitely more than you would have like the main Airflow cluster. It also brings about an interesting use case where you might be using Airflow to run some kind of inference job, some kind of LLM job, which needs high memory or high CPU. I don't have to scale out the workers of the Airflow cluster itself. You kind of decide the very nitty-gritty resource configurations of your tasks, and Airflow just runs it for you. A pretty similar architecture on the temporal side. So everything is kind of sits behind an ALB. We wrap everything around an ECS cluster, which has some security configuration, some network rules. So we kind of control who gets access to our cluster. And then we expose all our developers to access the temporal UI with some kind of an auth layer to kind of enforce security. Our temporal clusters are backed by Cassandra, which we get through a vendor, and then we use Elasticsearch for advanced visibility. And here again, the interesting thing are the two boxes on the left side. Now, these ECS tasks, these temporal workers, these could be running in your ECS cluster, which could be very different from, let's say, the one that I run at Instacart in the infra group, or the one where we host our temporal servers. As long as you have established the right security connection, the right network connection, you can deploy you can deploy hundreds of workers in your cluster with your specific configuration, with your specific, let's say, wrapper or image of choice, and then you are able to run your code on it at the scale at which you want. The central orchestration system is kind of independent from your workers. Now, because the worker plays such a critical role, and the workers are actually the execution unit, and the workers are actually the unit that scale out and gives you that power that you can run large-scale workflows here, we kind of build a lot of wrappers over the years on like the core primitives that these platforms provide. So Airflow has an Airflow worker, Temporal has a temporal worker, and then we kind of wrap them in different layers and different wrappers that we use at Instacart for any kind of service that we run. So we wrap the temporal SDK under our own wrapper SDK. We run it through our own middleware, which allows us to plug in like the same logging library, the same metric library, the same error reporting library, and so on. And then we deploy it in our opinionated way on Amazon, which we use through our own wrapper on top of Amazon ECS. Pretty similar for Airflow Worker as well. So the point being here is if you give your developers the same interface, like to them, it's just a normal application that they deploy. They'll use the same APIs to do logging, they'll use the same APIs to do metrics, and the same APIs to report any kind of error. They're just focusing on using a very standard middleware that they're used to, and they're focused on writing the actual business logic, which allows them to kind of scale out their workloads as well. And we on the platform side can kind of manage everything, and we get to also have an opinion on how things have to be done. Now, when you're talking about large scale, monitoring and alerting are like first-class citizens. And we particularly, because we run these large scale clusters, those are like strong emphasis for us to get right. So we build out monitoring at different layers. We build out monitoring at the platform layer, where we are monitoring the central orchestration system itself. Not just in terms of like the platform health, which could be, let's say, the Airflow scheduler heartbeat, or the temporal server error rates, or just in general CPU memory utilization across different core services of, let's say, temporal or Airflow. But we also allow, or we also give abstractions to our developers who are actually deploying the workers, which are the unit that they care about, and we give them easy to deploy resources to monitor their workers. And then the metric of that kind of is something that we abstract away under our paradigm as well. Which brings me to the next point, is a lot of that is possible because we embrace infra as code. At Instacart, we run Terraform pretty heavily. And what Terraform allows us to do is that it allows us to put everything in code. A lot of the monitoring abstractions in code, the worker deployment in code, whether the worker is being deployed in dev or in prod, it's deployed in a consistent manner. You can see everything that goes in, because everything is in source code, everything is a PR. So it goes through like a PR review process, which then kind of satisfies some of the auditability and compliance controls. And it's very easy to scale out the systems and reason about it, because again, everything is config and everything is in code. And an example of this abstraction that I'm talking about is this. So this line of code, this block of code here, is all it takes to deploy a temporal worker. You specify environment you run in, you specify the task queue, some names, the cluster, more granular control over how many CPUs you give it, what memory you want to give it, some environment variables, some internal settings, and then the command you want the app to run, the Dockerized app to run. In the same vein, We actually went ahead, and again, this has evolved over time, but this is our Terraform. This block of code allows us to deploy an Airflow cluster. We have built our own internal Terraform module to deploy Airflow. The module itself deploys a database, it deploys a broker, there's 3-bucket and a bunch of other things. You specify, so like this is a small set of config. You can go very deep into say that, hey, I want my scheduler to run these many nodes, these many CPUs, these many memories, and then you could do it same for the worker, the triggerer, and a bunch of the other processes. And while we deploy Airflow or the temporal workers or any other component, we actually have primitives that allows you to deploy monitors along with it. So this goes back to my point that monitoring and alerting needs to be central citizens when you're operating at large scale. So this is like a token example where we are building a Airflow scheduler heartbeat monitor in code. But imagine if you're deploying a temporal worker, I could be building like the module that deploys the temporal worker also deploys a Datadog monitor that allows you to measure some kind of metric, which is like a golden metric to measure the scalability or the latency that is happening on your worker itself. So that's all at the infra layer. Now, at the infra layer, the goal is to make it very easy for your teams to deploy applications, for them to kind of run any kind of Dockerized application that they have through whatever primitives you provide them. Now, in this, the example I gave before was a worker. This could also be an Airflow worker, and you are giving them like very granular controls on how to deploy this with enough configurations that are pre-built into this module. The moment this app gets launched, it's going to pull in the Docker image of your app. It's going to run this entry point and the command, and it's going to work out of the box for you. So a really easy step for your developers. And for a company like us, where we embrace infra as code, this setup is familiar because we deploy a lot of other services, databases, core infra, app level infra through the same paradigms. Now, one of the other layers of abstraction that we have built is we don't we allow, in some cases we allow teams to create native DAGs in the example of Airflow, but in most of the cases we have kind of abstracted all of that away and compartmentalized it into a YAML format. Now the YAML format for writing DAGs or workflows is fairly standard. There's nothing new. But I believe that this is a very powerful mental model to kind of onboard new developers and to kind of ship your developers. One, this gives you a way to be opinionated. It allows you to put a lot of guardrails and then allows you to do a lot of checking so that like unit testing or CI checking, so that when you're deploying these workers and these workflows at scale, you know where the break is going to happen, where the things are going to break. And then you have defined an opinionated way that anything outside of this template is not going to get deployed and it's going to fail at the CI layer. So this entire YAML template gets translated into a DAG in Airflow through like custom DAG generators that we write. And what it's essentially doing, the end user is basically filling out this template saying, hey, my Dockerized application name is this. It's running as this ECS task somewhere in some cluster. I've made sure that AWS connections are set up correctly. And the way Airflow has to run it is by calling this Python command. And so to the different personas that you have who use your systems, be it someone who is like software engineer or who is someone who's data engineer or someone who's an analyst, a format like this becomes really easy for them to understand. And then you can not just onboard software engineers or you just need software engineers, you can actually onboard a lot of data analysts and slightly less technical personas to your system as well. So then you are able to build systems that scale out in terms of different personas, in terms of different use cases, and then imagine a UI on top of this will help you fill this so that you are actually scaling it out to people who don't even want to create YAMLs or whose day-to-day job is not to create YAMLs. They're very comfortable in filling out UI forms. We generate a PR for them. We get that PR reviewed and merged, and then this translates into a DAG, which runs on the schedule that our end users provide. In a similar way, so this is an example of a DBT pipeline that runs at Snowflake. That runs at Instacart on Snowflake. So different engineers, they write their DBT models, And that's their main job. Their main job is to focus on writing the DBT models, writing the tests for those DBT models, and then filling out this YAML format. This YAML essentially is another DAG generator on the back end, which translates into a more formal Airflow DAG, which then runs all these different DBT models in certain upstream and downstream configuration as specified. So again, a really powerful way where your data engineers or your data analysts who are working on the main, so that their main job is to build those data models, their main job is to build those tables in Snowflake, their focus is on writing the SQL and the DBT model and less on writing the Airflow DAG or less on writing the workflow that translates that DBT model and runs it on Snowflake. So all that being said, now I'm going to move into the last part of my talk, which is going to be laying out few key takeaways that you can take back to your teams, whether it's a small team who's growing or you have a fairly large engineering team, and certain practices and best patterns that we have found that have allowed us to scale to more than 20 million workflows a day. The first one is something that I've talked about a lot, is abstractions and building wrappers. So if you give your developers the same look and feel as they have today of running whatever application they are running today, and then you give them the same logging library, the same APIs to do metrics, the same APIs to do tracing, it's going to give them a much familiar environment to work with. And then debugging becomes easier. It just kind of reduces the ramp up to using a new system. And that has allowed us to actually scale temporal within a matter of 4 years to over 21 million workflows every day. And it ranges from like a whole bunch of use cases. Because our developers are more focused on writing the business logic, and we have kind of abstracted away a lot of the complexity of the platform itself through the wrappers, through the abstractions. And then this has evolved over time. So you could start out by just focusing on the core worker primitive, deploying the infrastructure itself, letting your engineers play with it. But over time, you want to build out abstractions because you want to build out a common pattern through which you want everyone to use the service. And you want to have a say, you want to have an opinion because you're running the core platform, and the engineers are your tenants who are running the workflows. The second key takeaway is focusing on infra as code. Now, be it Terraform, be it something that Amazon or Google or any of these hyperscaler provides or any other technology, the idea is that if you enforce infra as code, not just when you're deploying the platform, but also when you're deploying other artifacts associated with that platform, be it monitors, be it alerts, be it so on, it just leads to a more consistent experience. Everything is defined as code. Everything is there in a repo that people can, check out. Everything is somewhere that, you could throw cursor at. Cursor can recommend 10 different things to you on how to set up something new because those patterns are already established. And lastly, it's focusing on declarative configs, which is basically, thinking about YAMLs. I kind of talked about a few examples earlier. The example on the left is an example of a data quality check that we run at Instacart. So we have a whole different system that runs data quality at Instacart. This is an example of like a sample check that runs there. All it's doing, it's running a SQL query against Snowflake. It's taking the result of that query, translating it into a Datadog metric, and emitting it in Datadog. Now, when the metric goes to Datadog, you can use any monitoring system that Datadog has, like a different type of monitors it has, dashboards, and so on, and you can monitor the metric depending on your use case. You could build an anomaly monitor on it, you could just build like a simple threshold monitor on it, or like a time series, you could visualize it as a time series. Point being, this YAML that you see on the left side is eventually translated into a temporal workflow. So bringing back to the earlier point which I had, or rather another example that I have is the one on the right, where teams bring in their apps, their Dockerized apps with like an executable for us to call in, we translate it into a DAG. So be it temporal, be it Airflow, we are actually investing a lot in building like an abstraction layer in the form of YAML, which kind of translates it back into like more formal workflows in those respective platforms. And this has allowed us to, again, scale out to those 21 million workflows that I talked about. So long story short, again, investing in abstractions, investing in config, being opinionated, kind of pays off when you're running large scale platforms, and then your tenants are the ones who are actually learning those scale out workflows. And with that, questions.